You've now modeled continuous dynamic systems in Simulink. Great work! But how does Simulink solve the system when you click the Run button? Well, as their name implies, the states in continuous systems update continuously over time. Simulink simulates the behavior of these systems by numerically integrating state values across time steps. All of this is handled by the solver. You need a continuous solver to solve systems that contain continuous states. There are two classes of solvers. By default, Simulink automatically selects a variable step continuous solver to ensure the accuracy of the numerical integration. So what does the solver do? Well, at a high level, at each time step, Simulink calculates the block's outputs, updates the continuous states, and determines the simulation step size to get the next time step. Let's look at how this process works with an example. When you click Run, the simulation starts at time 0. First, the block outputs are calculated. Some blocks' outputs depend on other blocks, so those blocks' outputs need to be calculated first. Since this order is the same for all time steps, Simulink initially analyzes the model and automatically determines the block execution order. You can use an information overlay to view the block execution order. In this example, you might be wondering why Simulink computes the integrator block's output first. Well, the reason is because it contains a continuous state, and its output at time 0 is the state's initial value, which doesn't depend on any other blocks. Starting from the integrator's output, the block's outputs are calculated in sequence. After all the outputs are obtained, Simulink updates the continuous state by numerically integrating the integrator block's input. The variable step continuous solver makes sure the integration error is within tolerance by reducing the step size when necessary. The same process then repeats at each time step until the end of the simulation. Now it's your turn to explore how Simulink solves your model.